Hi, Algebra 1 students. Quick introduction to working with order of operations. And if you're on social media, you may have had one of these pop up on your feeds where you see some sort of math problem and it says, most people won't get this. Post your answer in the replies, and people begin to argue about it. But it's pretty common in algebraic equations that we end up with mixed operations. So we have some multiplication, some addition, some exponents, and there are rules to keep everything in order so that everybody who does the problem will get the same result, the correct result. And so whether this is new to you or a review for you, we'll take a little bit of time to make sure that we can properly process order of operations in simple mental math kind of problems like the one shown in this meme. So the key to helping you solve problems like this, where you have all sorts of mixed operations, is a concept called Pemdas. And I found out that in different countries, they use different letters to call it different things, but Pemdas is a convenient little way to remember the rules of order of operations. So if we have a problem like this, we know what order to do things in order to get the correct answer for the way this problem is set up. So we have some different things here. We have an exponent right there. We have addition in a couple of places. We have division in a place. So we have all of these different little operations that we need to take care of, and we need to know in which order we should be either doing the mental math, which will be a lot of the practice exercises that we do, or in order to plug the numbers into our calculator in the right order. So PEMDAS is 6 words put together. So the P in PEMDAS is for parentheses. The reason that we use these parentheses in mathematical expressions is to group things into a particular part of the order of operations. So you can think of our parentheses here around 16 plus negative 13. Those are kind of locked in their own little bubble from the 2 squared plus 27. So we'll take care of everything that's in those parentheses as its own individual little unit. So P for parentheses, and then E is for exponents. So like our, get rid of these arrows, I don't need them right now, like our square of 2, 2 to the power of 2. So that's going to come in next. And then we have M and D are for multiplication and division. So the M and the D, and those actually carry equal weight in PEMDAS, so they're kind of at the same time together. And the way you would choose the order is that you always go from left to right. And so you would do, if you just have nothing that's but a string of multiplication and division, you would go start on the left and do things in order toward the right at the end, just like we read in the English language. And then the A and the S, as you might already know, stand for addition and subtraction. Addition and subtraction. And the same thing, they carry equal weight in PEMDAS, And so when you have a sequence of those, you would carry them out in order from left to right. So parentheses, exponents, multiplication and division, addition and subtraction. That's our order for PEMDAS. So if I try and take all of this out here, oh, that didn't work very well. Notability is letting me down a little bit. Let's see if I can get here. Oh, now you people that like things neat will get annoyed. Okay, got that cleared off. And let's take a look now at our problem that we had. So we're going to start with our P, our parentheses. So I want to take care of everything that's inside these parentheses first. So this is a mental math problem. 16 plus a negative 13, that is 16 minus 13. And so that becomes 3. So now my problem is 2 squared plus 27 divided by 3. I've cleared out all the parentheses, so now I'm on to the exponents. So my 2 squared right here, so 2 squared, 2 times 2 is 4. So now I have 4 plus 27 divided by 3. And our next section is going to be multiplication and division. So the next thing that I do is my division, 27 divided by 3, which is 9. 4 plus 9, so that means the solution to this problem is 13. This is kind of a straightforward example of PEMDAS that includes, all of the examples. I'm going to give you a sheet that will give you some practice problems of trying to apply this. Maybe before we go on to that, I'll give you one more example of PEMDAS, and then again, we'll give you some practice and see if you can do this. Then we'll sort out any questions that you may have in class later on. So, hey, that's not bad. So let's take a random problem and say 4 times 2 divided by 9 minus 8 squared plus 47 times negative 2. All right, let's start with our parentheses first. So the P in PEMDAS, 9 minus 8 is 1. So I'm going to end up with 4 times 2 divided by 1 squared plus 47 times negative 2. Next in PEMDAS is the exponent. So I'm going to square the 1. So 1 times 1 is 1. That's easy. I like that kind of math. Divided by 1 plus 47 times a negative 2. Then we do multiplication and division. So I have a multiplication and division right next to each other here. So I work from left to right. So 4 times 2 is 8. Is 8 divided by 1 plus 47 times negative 2. 8 divided by 1 is 8 plus 47 times negative 2. And then I hit addition. And I still have a multiplication left, so I have to do this before I move on to the addition subtraction part of PEMDAS. So 47 times a negative 2, this is maybe toward the higher end of our mental math. A way you can tackle this is that you take your 40 times 2 plus 7 times 2. So 40 times 2 is a pretty easy one, 80. And then 7 times 2 is 14. So 94 is 47 times 2. And then because I have a positive times a negative, that means that the ending answer is going to be negative. So we end up with 8 plus negative 94. And so if I take a positive 8 and a negative 94, again, this is toward the high end of our mental math, but we would end up at 86 is our final answer. Um, this maybe helps if you take it and you turn this around the other way and say it's negative 94 plus 8, and then you can see how we'd be counting toward the positive end, and we'll work with number lines a little bit of this, where if I'm, wow, that's a bad line. If I'm 94 here, negative, and this is negative 93, and negative 92, negative 91 on my number line. So I'd be bouncing 1, 2, whoop, it thought I wanted a line. I would be bouncing 1, 2, 3, 4, 5, 6, 7, 8, all the way back to, ooh, caught myself by doing that, negative 86 is my final answer.